underfitting, and overfitting. Overfitting. Overfitting is one of the common challenges when it comes to data mining projects. So simply overfitting is where your model tries to memorize all the data points instead of trying to find a good fit that could represent them all. So as you can see in this example, the polynomial line, as you see, it keeps wiggling, going up and down, try to fit all as much as possible of the data points. Now, this is not a good representation for the model, since this means if you got new data points, your model will not generalize well. That means the performance is going to be poor when you apply on unseen data. And one thing to keep in mind to understand it, that as you try to memorize everything by heart, as I said earlier, the student example, that means instead of the student putting effort to understand the general concept, to generalize well to the course, he's trying or she's trying to memorize everything. So in other words, if later they are challenged with seen examples that they studied earlier, including the numbers, then they will do very well. But once you try to give them unseen examples, then they will show very bad performance. And this is exactly what overfitting means. The reasons behind having overfitting is your model is too complex. As you saw in the previous example, the model was using high polynomial degree, and that makes the model too complex so that it tries to memorize every data point instead of generalizing to the data points in general. Or another problem is where you have noises inside your training dataset. How to recognize if your model has a sign of overfitting? The general concept that you can use is where you check on the modeling error. You will notice when you apply training dataset, the error is going to be low. But once you apply unseen dataset or the test dataset, then the error is going to be high. That means your model, the generalization error is high. So once you compare between the training error and the generalization error, you see that in training error was low while in generalization error was high. So this indicates you have overfitting case. Now, how to deal with overfitting? Overfitting can be solved with several steps. The first one is try to simplify or regularize the model. So simplify means that instead of having two complex models, you try to select a model with fewer parameters. So if we are talking, for example, on linear regression, then in this case, instead of having a high degree polynomial, we try to reduce the degree to a lower one. As a result, that means you are trying to reduce the number of attributes or features in the training data. Or by constraining the model by applying regularization. So regularization is a hyperparameter that can be applied to also put constraint on the model to ensure that it doesn't overfit the data set you have. Another option is to get more training data. The third option is to clean up the training data from noises. So how to control regularization? You can control regularization by the hyperparameter offered during the learning process. So hyperparameter is a parameter of a learning algorithm. As such, it's not affected by the learning algorithm itself. It must be set prior to the training and remains constant. Now, what will happen if the regularization value is very high or very large value? In this case, you will get an almost flat model. That is slope close to zero. In other words, your fitting line is going to be almost horizontal line where the slope is close to zero. And in this case, the learning algorithm will almost certainly not overfit the training data, but it will be less likely to find a good solution. So that means you might end up also in underfitting case because you are applying large regularization value, where it will like penalize the model to make big constraint on the model, so the slope will be close to zero. Underfitting. Now we already understood what overfitting means. That means your model, instead of trying to generalize to the data, to the pattern that we have, in this case, the model is trying to memorize by heart your data set. So whatever data you are feeding to the model, so your modeling is trying to find something that can fit them all as much as possible. And this is of course not good case, because in order to fit them all, that means you are going to apply high degree polynomial. And after all, we already discussed you're going to have high generalization error. Now the underfitting is just the opposite. That means your model is too simple to capture the pattern inside your data set. So as you see on the left hand side, we have underfitting case where the linear line won't be able to represent or capture the pattern inside your training data set. So as just the opposite of overfitting, here underfitting also, the performance is going to be poor as well. But there is something common to differentiate between them too. We already spoken that overfitting, the training error is going to be low, but the generalization error or the test error is going to be high. While in underfitting case, the training error is going to be high and test error is going to be high as well. Because anyway, your model doesn't represent or doesn't capture the pattern inside your data. So it doesn't matter whether you are testing using training data set or test data set, the error is going to be high in both cases. While the best scenario where you have the optimal fitting, where your model is just good enough to capture the pattern inside your data. So, and it's neither overfitting where it tries to memorize everything, or underfitting where your model is very simple or too simple to capture the pattern inside your data. And in this case, the training error is going to be low, as well as the test error is going to be low as well. The reasons behind of underfitting is the model is too simple. That means, let's say you are applying linear regression on a data set that has a U-shaped pattern, where in this case you're supposed to use, for example, quadratic or high degree polynomial, not just the first degree, right, of linear regression. And another matter, you might have irrelevant data, so remember garbage in, garbage out, and the model is constrained. For example, you have applied high or very large value on regularization hyperparameter that has constrained your model from being, let's say, flexible enough to capture the pattern inside your data. So as a remedy for underfitting is, number one, select a more powerful model, let's say with more parameter. In other words, if we are talking about linear regression, then we might be interested to apply high degree polynomial. Okay, now a second remedy is feeding better features. So in this case, we may be interested of applying feature engineering. And in feature engineering, which may include the following actions. The first one, you can apply feature selection. That means you try to find the most useful feature that contribute to your problem, to the target variable. Another matter or another choice is to use feature extraction, where you try to combine existing feature to produce a more useful feature. And in this case, you may be interested to apply dimensionality reduction. Remember, dimensionality reduction will try to produce new features, new dimensions, or we call them components, that are representative to the earlier features. And then, of course, we drop the original features. Or another case where you try to create new features by applying or gathering new data. How to determine if you have overfitting case or underfitting. So in other words, what we need to do, we need to get an estimate of the model generalization performance. And the best way to do it is by applying cross-validation. So cross-validation is going to help you to get an estimate of the model's generalization performance. Now, after we get it, then we need to decide based on the training error and cross-validation. That means on the validation error. So either we get high training error and high validation error or test error, then we consider this underfitting. Or if the training error is low, but the test error is high, then overfitting, then the case is overfitting. Now we come to model selection. Now, model selection is the process which will determine which model is better, but during the model building. So as the algorithm is working, we might have several options of models that are being built, and then we are interested to know which model is a good choice to consider during the learning process. And the objective of this step or this process is to try to avoid overfitting. And where we do that by estimating the generalization error, which can be done by either using validation set or incorporating model complexity while we are calculating the error. And then we will move to discuss about how to evaluate our model. After we build our model, we need to know how to evaluate the model. So in this section, we are going to discuss several techniques about model evaluation.